using priority rules to manage waiting lines. In many cases, we cannot avoid waiting lines entirely. And in this case, when we have multiple customers waiting, we might think about what's the right order to serve those customers. There are two ways to approach this. Either we can decide who goes first, who's served first based on service time, if we, of course, can estimate it, or we can use other rules that are independent on service time. Now, if for some reason you know how long the service time will be, you might decide to use the shortest processing time. I like the example of answering student questions. If I can quickly answer the short questions, if I have 3, 4 students and they ask me questions and I know, for example, 1 or 2 students who have a very short question that requires a yes/no answer, I first answer those and then I reduce waiting time, on average waiting time for everyone, and the students who have a very, a large set of questions are the only ones that remain, and they are maybe even willing to accept longer waiting time if they have a lot of questions. So shortest processing time rule, it actually is the rule that will minimize average waiting time. It will even minimize the variance of waiting time, so how much the waiting time varies. And also it will minimize average flow time, which includes waiting and service time, but not, in fact, not variance of flow time. More commonly used are service time independent priority rules. Why? Because these rules are more practical, because in most cases we don't know the service time, or we have no easy way of estimating it. Everybody will tell you, I have a short question, but they may end up asking a very long question, or maybe the question is short, but the answer is very long. So the most common rule, of course, is the first come, first served. Sometimes it is also called first in, first out, right? This actually will minimize the variance of waiting time and the variance of flow time, right? It is also, of course, the rule that is usually considered fair. If you use any other rule, people might perceive it as unfair. However, there are cases where the other rules, other than first come, first served, are applicable or are actually useful. One is urgency, right? This is where we use actually triage in hospitals. If you have a case where somebody may die in the next 5 minutes, you'd rather give them priority over someone who just has a common cold, right? And then financial or banking services or other, you might have an importance. So you might want to say these are premium customers who have a lot more money that we manage for them. So therefore, maybe we'll assign higher importance to them and then give them priority over customers who are less important for one reason or another, right? For any service time independent rule, expected waiting time does not change. So, right, so to be able to reduce expected waiting time, you have to use a rule that is somehow correlated with the service time. So here is an example of a process. Suppose we have 4 tasks or 4 customers waiting. One, A needs 9 minutes of service, B needs 10 minutes of service, C 4 minutes of service, and D 8 minutes of service. And suppose they've arrived some time ago, and then now we start serving them. They arrived in this order. So let's say if we serve them in the first come, first served basis, this is the kind of Gantt chart that you will have. Right, on the horizontal axis, there is the time, and you see A takes 9 minutes, so everybody else waits 9 minutes. Then B is served, the service time is 10 minutes, and so the C will wait in total 19 minutes, 9 and 10, and then when C is served for 4 minutes, D will wait, and that waiting time for D will be 23 minutes. So if you average the waiting time, it will be 12.75 minutes. If you average the flow time, so we have to actually look at waiting plus service, it will be a total of 20.5 minutes. And you can also calculate variance of waiting time, which is 106.9. Now, if you apply the shortest processing time, you have to sort these customers. So if you have all 4 of them available from the beginning, right, I will say, well, 4 minutes is shorter than everything else. I will serve customer C first, then D 8 minutes, then A 9 minutes, and then B 10 minutes. Right? If you do this, the waiting times 0, 4, 12, and 21. So the waiting time on average is 9.25 minutes, and you see that is less, right? And actually not much less, but significantly less than 12.75. Average flow time is also reduced from 20.5 to 17 minutes, and variance is also reduced, right? So all above measures are minimized by shortest processing time. This is what we know. If you apply shortest processing time, you'll minimize average waiting time, average flow time, and variance of waiting time.